Okay, today we're going to be solving systems of equations using elimination. So let's go through our method, our step-by-step process of what we're going to be doing. So number one, write the system so that like terms are aligned. And by like terms, I mean all our x's are in one line and all our y's are in one line. Or a's and b's, whatever your variables are, you need to make sure that they're aligned. Step 2, eliminate one of the variables and solve for the other variable. Okay. Step 3, substitute the value of one variable into one of the original equations and solve for the other variable. And like I said, we're going to do a couple examples so this will all make sense in just a few minutes. Step 4, write the answers from steps 2 and 3 as an ordered pair, and we always write our ordered pairs with parentheses, x comma y, and then check. Okay, so let's do a couple examples together. Alright, I've got 2x plus y is equal to 3, and my other equation, I'm going to make it in green, is negative x plus 3y is equal to negative 12. Okay, so the first thing that we're doing is we're going to be adding these equations together. And in step 1, well, first we need to make sure that our like terms are aligned. So, okay, our x's are all in line, our y's are in line, and then on the other side of the equal sign we just have numeric values. That's okay. So everything's good. Step 1. Alright, so now we need to eliminate one of the variables and solve for the other variable. So in order to do that, we have to add the two equations. Well, if I add these two equations right now, I'd get 2x minus x, which would give me 1x, and y plus 3y, which would give me 4y's. Well, so I'm not eliminating any variables at the moment. So we need to do something to one of these equations so that I can eliminate a variable. So right off the bat, I see that if I multiply this x by 2, 2x minus 2x will equal 0, and one of those variables will go away. So let's do that. Let's multiply this bottom equation by 2. And as we always know, whatever we do to one side of the equation, or of the equality sign, we have to do to the other. So I'm going to rewrite my first equation down below. I'm not doing anything to it. And now I'm going to multiply every term by 2. So I get negative 2x plus 6y equals negative 24. Okay, now I'm at a point where I can add them because I see that my x's are going to cancel. Now y plus 6y, I get 7y equals negative 21, right? Then I divide by 7 on both sides, and I'm left with y is equal to negative 3. So I've got my y. Okay, so now step 3. Substitute the value of one variable into one of the original equations, meaning this equation or this equation. So let's take this and put it right in there for the y. So get 2x plus negative 3 is equal to 3. And let's solve for x. We're going to add 3 to both sides. So 2x is equal to 6. Divide by 2, and we get x is equal to 3. Alright, but we're not done yet. Remember, we're going to write our answers in ordered pair. So our solution will be 3, negative 3. And that means that these two lines intersect at the point 3, negative 3. Okay, let's do our second example. We've got the equation 2a plus b is equal to 5, and 2a plus b is equal to 7. Those are our two equations. Oops, I meant to write one of them in green. I like having two different colors so we can clearly see what our equations are. Okay, so alright, step 1. Write the system so that like terms are aligned. Well, my a's, my b's, all, okay, check. They're all lined up. Step 2. Eliminate one of the variables and solve for the other. Okay, remember we're adding our two equations. If we add them, does anything get eliminated? Nope, I'll get 4a here and I'll get 2b here. So that doesn't work. Well, what if I multiply one of these equations by -1? Then I'd get a negative b plus a positive b, and my b's would cancel. So let's multiply this green one by -1. So I'm going to rewrite my top equation down here, not doing anything to it, and I'm going to multiply every term in this equation by -1. So -2a minus b equals -7. And I'm going to add the two equations together. 2a minus 2a, well, that's 0. Okay, these cancel. B minus b, that's 0. Those cancel. 5 minus 7, -2. So, does 0 equal -2? No, it does not. So remember, what did that mean? That means that we have no solutions. And if we can think back to some previous notes, that means that we've got two parallel lines with the same slope, right? They're never going to intersect. Okay, let's do example number 3. Write my first equation. I've got 12x minus 2y equals -30. And y equals 6x plus 15. Okay, well here we come across something that we haven't seen yet. So we've got step 1, are my like terms aligned? Well, we see that they're not. So we've got to do something to get our terms aligned. So in this top equation, we've got x's plus y's is equal to a numeric value. And here we've just got y's. So let's bring our x's over to the other side. In order to do that, we have to subtract 6x from both sides. So we get -6x plus y is equal to 15. And let's just double check. We've got our x's in line, we've got our y's in line, and we've got our numeric values. So I'm just going to rewrite that top equation down here. I'm not doing anything to it. I'm just rewriting it. Okay, now I can add my equations. And remember, step 2, we're trying to eliminate one of the variables. Well, -6 plus 12 is 6x's, so those won't eliminate. Y minus 2y, I'm left with -y, so that doesn't eliminate. So I have to do something to one of these equations. And you guys might think of a different way than I do, but that's okay. So here I'm going to take this equation, my -6x's, and I want to multiply them all by 2, because if I multiply -6 by 2, I'll get -12x, so my x's will cancel. So that's perfect. Okay, so I'm going to get -12x plus 2y equals to 30. And my bottom equation is 12x minus 2y equals to -30. Okay, I'm going to add them together. Those cancel, so I have 0 plus 0. And 30 minus 30 is 0, so 0 equals 0. Remember, that's a true statement. 0 does indeed equal 0. So that means that I have a line on top of a line, right? And I have infinitely many solutions. Okay, and that's it.